Safety Toolbox Talk number 256. Human Factors Engineering. Human Factors Engineering, HFE, in Safety Management Systems, SMS, focuses on designing systems, processes, and environments that optimize human well-being and overall system performance. Below is a detailed, point-wise breakdown of how HFE integrates into SMS. 1. Understanding human capabilities and limitations. Physical factors. Consideration of human physical capabilities, such as strength, endurance, and dexterity, to design tools, equipment, and workstations that minimize strain and injury. Cognitive factors. Design systems that align with human cognitive capabilities, including attention, memory, perception, and decision-making. Psychosocial factors. Address the impact of stress, workload, fatigue, and team dynamics on safety and performance. 2. System design and user-centered approach. Ergonomic design. Create tools, equipment, and environments that fit the user, minimizing discomfort and risk of injury. User interface design. Ensure that controls, displays, and interfaces are intuitive and reduce the likelihood of human error. Workplace layout. Optimize the physical layout to facilitate safe and efficient workflows, minimizing unnecessary movement and the potential for accidents. 3. Error prevention and management. Error proofing. Pokyok implement design features that prevent errors or make them immediately detectable. Redundancy and fail-safes. Incorporate multiple layers of protection to ensure that if one element fails, the system as a whole remains safe. Standardization. Standardize processes, procedures, and equipment to reduce variability and potential for error. Four. Training and competency development. Simulation-based training. Use simulations to replicate real-life scenarios, allowing workers to practice and develop their skills in a controlled environment. Behavioral training. Educate workers on safe practices, including recognizing and mitigating human errors. Competency assessments. Regularly assess worker competencies to ensure they can perform tasks safely and effectively. 5. Human-centered risk assessment. Task analysis. Break down tasks to identify potential human errors, and design controls to mitigate those risks. Human reliability analysis. HRA. Assess the likelihood of human error and its potential impact on safety. Behavioral observation. Monitor and assess worker behaviors to identify trends or practices that could compromise safety. Six. Communication and reporting systems. Effective communication. Design communication systems that ensure clear, concise, and unambiguous exchange of information. Incident reporting. Encourage a non-punitive reporting culture where workers can report near misses and incidents without fear of blame. Feedback loops. Establish mechanisms for continuous feedback, allowing for real-time adjustments to practices and procedures. 7. Safety culture and organizational factors. Leadership commitment. Ensure that leadership prioritizes safety and human factors in decision-making processes. Safety climate. Foster a positive safety climate where workers feel responsible for their own safety and that of their colleagues. Continuous improvement. Regularly review and update safety practices based on new insights from human factors research and operational experience. 8. Workload and fatigue management. Workload assessment. Balance workload to prevent cognitive overload, which can lead to errors. Fatigue management. Implement policies that address work hours, rest periods, and recovery time to reduce the risk of fatigue-related incidents. Shift work considerations. Design shift schedules that minimize disruption to workers' circadian rhythms. 9. Environmental design and control. Lighting and visibility. Ensure adequate lighting in work areas to reduce eye strain and improve focus. Noise control. Minimize noise levels to prevent distraction and reduce stress. Thermal comfort. Maintain appropriate temperature and ventilation to ensure a comfortable and safe working environment. Incident analysis and lessons learned. Root cause analysis. Investigate incidents to identify underlying human factors contributing to the event. Learning from incidents. Use findings from incidents to inform future designs and training programs. Systemic changes. Implement changes across the system to prevent recurrence of similar incidents. 11. Integration with technology. Automation design. Ensure that automation supports human operators and does not lead to over-reliance or complacency. Human-machine interface (HMI) design interfaces that support easy interaction between humans and machines, reducing the likelihood of operator error. Adaptive systems. Implement systems that can adapt to different user needs and scenarios, improving overall safety and performance. Regulatory compliance and standards. Adherence to standards. Ensure that all safety systems and practices comply with relevant human factors and safety standards, e.g. ISO 45001. Regulatory reporting. Maintain accurate records and report incidents as required by regulatory bodies. Continuous audit and review. Regularly audit safety systems and practices to ensure ongoing compliance and identify areas for improvement. Thank you.